This is the sixth video in our quadratics topic, and we are looking at a process called completing the square. Now this should have been introduced to you when you did expressions in Formula 1.2, but it wasn't. So we're going to introduce it now, and anybody who's missing that assessment standard question in their assessments can pick it up now. Okay, so by the end of this video, you will know what completing the square form is, be able to write a quadratic in completing the square form, and state the turning point of the quadratic from completing the square form, and write a quadratic in completing the square form from the graph. Okay, so this is quite an extensive video, but hopefully we've got enough examples in here that you'll be able to pick it up. So completing the square form is when you take the quadratic ax squared plus bx plus c and rewrite it in the form a x plus p all squared plus q. Okay, and a will always be 1 at National 5 level. When you move into higher, a will not be 1, but at National 5 level, a is always 1. So there we have an example here. We have x squared plus 4x minus 8, and we want to write it in the form x plus b all squared plus q. So let's get my pen tool. And what we have to do is really straightforward. We need this to look like this. So what we're going to do is we're going to multiply this out in full so that we can compare this with this. So if I multiply out x plus p all squared, I will get x plus p times x plus p plus q. Okay, so x plus p times x plus p, we multiply out those brackets, we'll get x squared plus px plus another px plus p squared plus q. And if I collect my like terms, I'll get x squared plus 2px plus p squared plus q. Okay, right, so now we have this in quadratic form. And if I change the colour of my pen, I'm going to go for highlighter. And what we will find is that we can now do a comparison. We have 2px, and that has to be the same as positive 4x. And I'll change to a different colour then. And then now we have p squared plus q, and that's got to make negative 8. So that's the next thing I'm going to do. I'm going to set myself up two equations. 2p is equal to 4, and p squared plus q is equal to negative 8. Okay, so I can solve this for p. I will get that p is 2. And now that I have p, I can substitute it into this equation here, and I will get 2 squared plus q equals negative 8. So 2 squared plus q is, 2 squared is 4, so 4 plus q makes negative 8. Well, 4 plus negative 12 makes negative 8, so then q is negative 12. So that means when I go to rewrite this in the form that we're looking for, with a red pen, what we're going to have is x plus 2 all squared, and then minus 12. And this expression and this expression are exactly the same, and if you're unsure or you don't believe me, you can always graph them. If you use Desmos, it will graph these exactly for you. Okay, right, so let's move on and take a look at another one. So we've got to write x squared minus 6x plus 18 in the form x minus p all squared plus q. Okay, right, so again, I'm going to multiply this out, and I'm going to have x minus p times x minus p plus q. If I multiply this out, I get x squared minus px plus p squared plus q. collecting my like terms, I'll get x squared minus 2px plus p squared plus q. Okay, and again, I've got that x squared, that x term to match up, and that p squared plus q term to match up. So I've got negative 2p is equal to negative 6. So then p is equal to 3. And then p squared plus q is equal to 18. So I got 3 squared plus q is 18. Well, 3 squared is 9, so 9 plus q is 18. And then we all know that 9 plus 9 is 18. So q is equal to 9. Okay, and then if I change my colour, let's go for a different colour time now. Let's go blue. This, in completing the square form, is x minus 3 all squared plus 9. Okay, and again, if you're unsure or you don't believe me, graph the two of these on the same thing and you'll see that they are in fact absolutely identical. Okay, so how about a more challenging example now? Okay, x squared plus x plus 3 in the form x plus p squared plus q. Okay, right, so we've already multiplied x plus p all squared plus q. What we got is x squared plus 2px plus p squared plus q. So now let's do a comparison. 2p is equal to 1, so then p is a half, and p squared plus q is equal to 3. Fill this in and we've got a half squared plus q making 3. Well, a half squared is a quarter plus q is 3. Well, a quarter plus 2 3/4 makes 3, so q is 2 3/4, or if we're writing this as a single mixed number, then we are looking at 11 over 4. Okay, and then I'll change my colour to green now. Putting this all in, I get x plus a half all squared plus 11 over 4. Honestly, you're unlikely to get one as difficult as this, but it's best to be prepared, especially if you're going on to higher, that you need to be able to work with fractions. Okay, so that's how you actually take it from a quadratic expression multiplied out to a quadratic expression in completing the square form. Now we need to work out what's the purpose of writing it in completing the squared form, and that's what the next part of the video is on. Here is the graph of x plus 2 all squared minus 12, which if we take a look back a few slides is what we got here. X plus 2 all squared minus 12. Okay, now your roots are not distinguishable in this, they're not exact, but what is exact is your turning point. Your turning point is here, and the turning point happens at negative 2, negative 12. And hopefully you can all see that. Back 2, down 12. So negative 2, negative 12. And from this, we can get the generic statement that your turning point in completing the square form is negative p cubed. So the opposite of whatever your p value is, q, okay, as a general rule. And you can always check these. Gee whiz, that does not look like rule. You can always check these yourself by graphing them and making sure that I'm not telling you any porkies, but I can assure you I'm not. That is the general rule for how you find the turning point of a quadratic in completing the square form. So as a general rule, we're looking at negative p cubed. Okay, right, so the next two examples are the two examples that we did following this one. Okay, so we have x minus 3 all squared plus 15. I'm going to change the colour of my pen back to purple. Okay, so if these are my examples, Then the turning point for this one is 318. And what that also means is that our axis of symmetry is at x equals 3. So if we go back and look at this one, our axis of symmetry is x equals -2. No further manipulation is needed. All you're doing is reading some information off the graph. So our final example, x plus a half all squared plus 11 over 4. Our turning point is negative a half, 11 over 4. So the opposite of what P is and then what Q is. And then our axis of symmetry is at x equals negative a half. Okay, and just to make sure that I'm right, you should definitely go and graph these functions on Desmos, and they'll show you exactly what I'm talking about, and you'll see it really clearly. Okay, so that's the purpose of completing the square form for some of our needs, is to state the turning point. Okay, but from completing the squared form, we can also state an equation for the graph. So let's take a look at this example here. I want to state the equation of the quadratic opposite, right? Because we know about quadratics in factorized form already, we know that this can be written as y equals x plus 5 x plus 1, because those are our two roots, -5 and -1, so x plus 5 and x plus 1. Okay, but that's because this equation has roots. Okay, that you can do that. Completing the squared form works for all these equations because every single quadratic has a turning point. So in this one, it would be x plus 3 all squared minus 4, because my turning point is here at -3, -4, opposite of P, Q. Okay, and our turning point, we can write that in as -3, 4. Okay, and that is how we state the equation. So this one had roots, so we've got two options for stating the equation. This one has no roots. You can see that clear as anything. It does not cross the x-axis, and it never will cross the x-axis anywhere. Completing the square form is the only way that we can write the equation of this quadratic. Looking here, you can see your turning point happens at 1, 2. So your equation is going to be y equals x minus 1 all squared plus 2. Okay, and it's as simple as that. And your axis of symmetry for this one would be x equals 1. Okay, so let's go back and review everything and just check that we've covered it all. So hopefully now we do in fact know what completing the square form is, and we can rewrite a quadratic into completing the squared form. You've definitely seen examples of stating the turning point of the quadratic from completing the squared form, and you've also seen two examples of writing a quadratic in completing the squared form from the graph. So I'm pretty sure we've covered all of these.